All right, so our activity that we did kind of introduced us to exponential functions. Let's take a look. So what is an exponential function? You were given this problem. Would you rather have $1 million or a penny that doubles each day for the month of May? And explain. So you went through, one of the things that you might have done is just done a little bit of plug and chug. Started with the first day, you knew you got a penny, and then just doubling that every time. And so you just multiplied. You just said, all right, from here to here, I'm multiplying by 2. Right? Every time I'm doing that, multiplying by 2, on down the line a bunch of times until I get to the very end, right? So I multiply by 2 down here, and this gives me my last one. Now, you'll see at the end of the month of May, you would have $10,737,418.24. So clearly, you would rather have that over $1 million. That's significantly more. But what happened? So this is multiplying a bunch of times by 2. So if I don't know how many times I'm multiplying by 2, right? If I say I'm multiplying by 2 3 times, another way to write that would be 2 to the third power. Well, if I'm multiplying by 2 7 times, I would go 2 to the 7th. If I don't know how many times I'm going to multiply by, I could say 2 to the x. This represents an exponential function. Okay, so I could write my equation y equals 2 to the x power. So this is an exponential function. There's another element that we have to add in here before we have our equation, but that would give us a little bit faster way to do this rather than plug and chug. But this is an exponential function. One of the things that I want you to take a look at is look at the first 10 days here. This is very slow growth. After 10 days, I only have a $5.12. So if you were to make a prediction after 10 days, whether you were going to hit $1 million, you would probably say, no, that's not going to happen. But if we get to the end of the month, you'll notice here, now it's really growing rapidly. And the reason for that is it's more money and we're doubling more money. So then that gives us more growth and more money each time we double. So this is one of the features of exponential functions, is that they have a kind of a slow growth and then a really rapid growth. We also have the same thing for decay as well, where it's decreasing. But this kind of helps explain that a little bit more. When you graph this function, y equals 2 to the x power, you notice here in this, maybe I use a different color here so you can see this. Notice in this spot right here, it is increasing, but it's actually so hard to see on that graph that it's because it's barely increasing. And then we get a little further out, and now we're starting to increase further, and then you can see this starts to increase the slope right there, and now we have a rapid increase. Okay, again, features of an exponential function. Okay, so again, exponential function. We just talked about exponential function to like y equals 2 to the x. This function right here is a quadratic function, which you're familiar with, where the variable is in the base, not the exponent. So this is a quadratic function, and you know when you graph it, you get a parabola, okay? This over here is called an exponential function because the variable is in the exponent, and in this case, when you graph this, you would get something like we just said, where you get this kind of slow growth and then rapid increase. Okay, so an exponential function. It looks like this. Now you say, well, these two aren't quite the same. Oops, these two aren't quite the same. Well, they are. I just have a number in front of that 2 to the x power would be 1. So what are the features? Well, your a value here, this is your starting amount. Okay, your b value, this base, this is your multiplier. What are you multiplying a bunch of times? And then the x here would be how many times are you multiplying that by? 10 times, 5 times, whatever. Okay. So let's take a look at our function here, right? Exponential function. So if I wanted to write this, rather than plug this all the way through, I would say, well, okay, my starting amount was A, and you can see that my starting amount here is a penny. Okay, so I could say, well, this is y equals 1 penny. Now, what was I multiplying every time? Well, we said it was doubling. So every time I did this, I was multiplying by 2, right? Multiplying by 2 all the way through. So I could say times 2 to the x power. Now then, if we wanted to figure out how many times we were multiplying by, I'd replace that x with a number. So then we want to look at this, and you got to be a little careful, right? When you do this, here I've multiplied once, but I have 2 numbers there. So how many, when I go all the way down to 31, down to here, I'm going to multiply 30 times by 2. Not 31, 30 times. So there are 30 spaces here, right? That's how many times I multiplied. You can go through and count that. But then if I put a 30 here, now I could type this into my calculator and see what I get. So let's see that hopefully we get 10,737, right? So let's go to our calculator, MCA calculator. We're going to type it in and see what we get. Okay, so I have penny times 2 to the 30th power. Notice I get $10,737,418.24. That is how we could have done that a little bit faster. So this matches what I have down here. And so that is an exponential function, and you can see the power of those in the growth. Okay, well, that's it. Next time we'll talk a little bit more about how these functions work. All right.